Hi, everybody. We're going to start parallel line proofs. So similar to the proofs that we've done earlier in this course in the last unit, we are going to extend them to parallel lines. So there's still two-column proofs, and you'll notice on the back of your theorem sheet that you have this box that we haven't touched yet, and that's because they're going to deal with all these parallel lines. So all of these are angles that we've seen in the past couple days: corresponding angles, alternate interior angles, exterior, alternate exterior, consecutive interior, and exterior. So all of those are going to be pretty familiar. So hopefully it's a good extension from where kind of marrying the two of those together, the proofs and then those extra theorems. So just as we had before, we have these two bullets here. One of them is the conditional statement. If two parallel lines are cut by a transversal, then the corresponding angles are congruent, which hopefully you know, but that's just the theorem, what we've been doing the last couple of days. And then we have its converse, which is also true. If two lines are cut by a transversal, so that the pair of corresponding angles are congruent, then the lines are parallel. So one is saying that you have your parallel lines, corresponding angles are congruent. The converse is saying that if corresponding angles are congruent, then the lines are parallel. Which is what we just did in the previous day, using those proving lines are parallel. So that's the converse here. And the conditional is what we were doing when we were doing all those activities. So again, hopefully all of this is pretty familiar with you, your two bullets, and it's all based off of, just like in proofs from before, where we started and where we're going. So the if part is from the previous statement, the then is what the statement we're in. Okay, so I'm going to go ahead and turn on my iPad, see if we can share here. Let's see. All right, so here you have your parallel lines. We have J and K, and just as we had before, we have we have our given statements and our proof statement. Now this one's a little bit different than what we're used to. If I were doing this proof, if I had some more space, I would probably add a few more things in there. But be that as it may, I'm going to kind of be limited to the 4 spaces that we have in problem number 1. All right, now some of these problems you can do in different directions, because remember you have all those corresponding angles and alternate interior angles. So some of them you can do in multiple ways, but just because of time constraints and space constraints, I'm going to go ahead and do it the way that's it was intended. All right, so for the given statement, of course, don't forget to label your steps. So angle 4 and angle 7 are supplementary. It's given. So let's take a look at what we're doing. So we have 4 and 7 are supplementary. Now, of course, I'm going to mark them up. I'm going to mark them up with different angle markings there because they're not congruent to each other. So we also know that 4 is congruent to 6 because they are alternate interior angles. So if I can state that 4 is congruent to 6, then I can say that 6, these are supplementary, and kind of go from there. So these two are supplementary, 6 and 4 are congruent. Oh, somehow I got rid of, no, I did not. All right, so let's go ahead and see what we have. So for step number 2, 4 and 7 are supplementary. We can also say that angle 6 and 7 are supplementary. They form a linear pair. So if 2 angles form a linear pair, then they are supplementary. Now, of course, this is where if I had done the problem, I would have probably stated in one step, the step above, if I had an extra space, I would have said 6 and 7 are supplementary or are a linear pair, so that I could then, in fact, use this linear pair here. So at this point, we're just assuming they're a linear pair, and that is something you can assume from a diagram. So you can assume that you have a straight angle, and then so you can assume linear pairs. You cannot assume right angles, so keep that in mind. All right, and this one we've seen before. This next one, if 4 is supplementary to 4 is supplementary to 7, and 6 is supplementary to 7, then 4 has to be congruent to 6. And that's because if you remember from the previous unit, it's your congruent complements theorem. If two angles are congruent supplement theorem. If two angles are supplementary to the same angle, then they are congruent. Again, if I don't know if you see me, but it's on the back of this page under congruent supplement theorem. All right, and then step 4, if we can say that 4 and 6 are congruent, then we can say that lines J and K are parallel, because if 4 and 6 are congruent, that means they're alternate interior. And then these lines, if they're congruent, have to be parallel. So I'm looking again at this page right here. These are alternate interior angles. So I'm looking at the second one here. So let me write my statement here. J is parallel to K. And then here we have so you have two bullets, and we're looking at the first one, the second one. Two lines are cut by a transversal so that a pair of alternate interior angles are congruent. Then the lines are parallel. So that's the second bullet there. I'm going to kind of shorten that up a little bit. That's pretty wordy. If two lines forgot the number 2. Two lines cut by transversal. So that sometimes mathematicians abbreviate such that as ST. So you want to think about that, such that alternate interior angles are congruent and the lines are parallel. All right, let's see in number 2. So for number 2, we know A is parallel to B. That's given to us. Whoops, it looks like I already have 1 and 2 marked up. So I might as well go ahead and write that in there. So I know A and B are parallel. And then from that, well, first of all, that's given. From that, we know that angle 1 is congruent to angle 2. And then they are alternate interior angles with those parallel lines. So you can say if two lines are parallel, then alternate interior angles are congruent. What else do we know? We know 2 is congruent to 3. And that's given. And then the age-old 1 is congruent to 2 and 2 is congruent to 3. So we can say that angle 1 is congruent to angle 3. And that's by your transitive property. No, looks like I still have my markings in number 3. So we know that 1 is congruent to 7. So let's go ahead and start that. So number 2, if we have congruent angles and these are alternate exterior angles, and if they're congruent, then we know these lines are parallel. So my next step would be to say that angle or line L is parallel. L is parallel to M. Oops, numbering. Let's fix that numbering up. And then for this one, I'm just going to write if alternate exterior angles are congruent, then the lines are parallel. Shorten that up, that if then statement up a little bit. All right, let's see. And our last one, we have L is parallel. What are we trying to prove? 4 and 8. So here's 4 and here's 8. Well, those are along L and M with the transversal there. So they are corresponding angles. So we can say that since line L and M are parallel, then I can say 4 and 8 are congruent. And then that would be the conditional statement. So if 2 lines are parallel, then corresponding angles are congruent. All right, number 4, 5 and 8 are supplementary. Well, 5 and 8 are consecutive exterior or same side exterior angles. So if they are supplementary, then I can say that line R is going to be parallel to line S. And this one would be if consecutive exterior angles are supplementary, then the lines are parallel. And then we're trying to show that 3 is congruent to 6. So let's see what we're looking at. So 3 and 6, well, they're alternate interior angles. And since we now have shown that R is parallel to S, we can say that 3 and 6 are congruent. This one would be if 2 lines are parallel, then alternate interior angles are congruent. All right, number 5. Yeah, C is parallel to D. So let's see what that gives me. Over here, sorry. When I zoom in, I can't see the pictures anymore. So I have to have my paper nearby. So C and D are parallel. Okay, so we're trying to eventually say that A and B are parallels, but we also know that 1 is congruent to 7. So let's kind of have a roadmap here. So we know 1 and 7 are congruent. And if, let's see, 1 and we have the C and D that are parallel. So you can say also 1 and 3 are congruent. 1 and 3 are congruent because of the parallel lines and they're corresponding. So it looks like then I can use my transitive property. If I can say 1 is congruent to 3, which is what I'm going to say next, We already know 1 is congruent to 7 because it's given. So using your transitive property, you can then say that 1 is congruent, or 3 is congruent to 7. Okay. And then once I know 3 is congruent to 7, then I can say my other lines are parallel. That's not the only way to do that, this problem. So keep that in mind. So the parallel lines that gave me 1 and 3. Angle 1 is congruent to angle 3. And that's if two lines are parallel. And corresponding angles are congruent. And then I'll use my second given. And angle 1 is congruent to angle 7. And then from there, I'll use my transitive property. So angle 3 has to be congruent to angle 7. And then if 3 is congruent to 7, let me erase my highlights there. If 3 is congruent to 7, 3 is along line A and 7 is along line B. So now I can say that since 3 and 7 are corresponding angles and they're congruent, then A is parallel to B, which is step number 5 here. So if corresponding angles are congruent, then the lines are parallel. Okay, let's see what we got going on here in this one. J is parallel to K. So J parallel to K. And we're going to have to say that 1 is supplementary to 7. So we're looking at trying to get to there. So let's see. We know 1 is supplementary. Well, we don't know that. We're trying to prove it. But I do know that if the lines are parallel, that 7 and 5 are congruent because they're corresponding. So I'm just kind of setting my roadmap. So if I can say these lines are parallel, I'll say angle 5 and angle 7 are congruent. And then I can say that these are supplementary. And then I can use substitution to say the other ones. Now we are going to use substitution. So I'm going to have to use my definition of congruence to change it to measurements so that you can do that substitution. You substitute with measurements, not congruency. So let's start with the first one. J is parallel to K. And that was given. Step 2, angle 5 is congruent to angle 7. And that one is if two lines are parallel. And they were corresponding, right? Yes, corresponding angles are congruent. And then I'll use my definition of congruence, which we used in the last unit. Measurement of angle 5 is equal to the measure of angle 7. Two angles are congruent, and they have equal measure. All right, so let's see here. We can see here that 1 and 5 are a linear pair because remember you can assume a straight angle, so you can assume a line. So those are a pair and they form a straight angle, so they're a linear pair. So I can say that angle 1 is 1 and 5. So angle 1 and angle 5 are supplementary. And that is using your linear pair theorem, which is on the back sheet. So if two angles form a linear pair, then they are supplementary. Okay, so let's see what we can say next. So 5, the measure of angle 1 plus the measure of angle 5 is equal to 180 degrees. That's your definition of supplementary angles. So again, that's on the front side of your sheet. Let's see, about halfway down. And so if two angles are supplementary, then their sum is 180. And from here, we'll do a substitution. Since I know 1 or 5 and 7 are congruent, I can substitute out, instead of a 5, I'm going to put a 7. And that's using substitution. And then the last one, angle 1 and angle 7 are supplementary. And that's if using that definition of supplementary angles again, the other bullet. So if two angles have a sum of 180, then they are supplementary. All right. I'm going to skip over number 7, but if you do try to, just for time's sake, if you do try number 7, I would recommend, I've tried this one, and I find it easier to replace those ABC with angle 1, 2, and 3. So if you want to write that down and give that a try, it's much easier to, all the letters kind of with different orders can be a little confusing. Let's see. Oh, number 8's a good one. Let's take a look at number 8. So number 8, R is parallel to S. So I'll take a look at that in just a second. That's given. And we also know that S is parallel to T. So R is parallel to S. And then S, what I just highlighted, is also parallel to T. So this one would be your transitive property, but using for parallel lines. So it is a transitive property. If two lines are parallel to the same line, then they are parallel to each other. So you can write it out that way if you would like, if that makes more sense to you. If two lines are parallel to the same line, then they are parallel. Or you can just simply state it's the transitive property. Now, my answer key, it says transitive property for parallel lines. I don't know if you need to be quite that specific, but if you would like to, you can. And I'm just going to write R is parallel to T. What that allows me to do in my picture, if R is parallel to T, I'm just unhighlighted S. We're trying to show that 6 and 7 are congruent. Well, 6 and 7, according to with R and T, are alternate exterior angles. So we can say that they're congruent. If two lines are parallel, then alternate exterior angles are congruent. All right, let's try number 10. Number 9 you'll also see coming up there. If R and 5 and 16, just kind of giving you a heads up there, 5 and 16 are here. They are consecutive exterior angles. That would mean if they're supplementary, then you can say P is P is parallel to Q. So you would start there, 5 and 16 are supplementary, that was given to you. So then you would say P is parallel to Q, because if consecutive exterior angles are supplementary, the two lines are parallel. So that would be kind of that proof part. You also know that 2 and 18 are congruent to each other. 2 and 18 are corresponding, and they're corresponding with line P and line R. So you could say 2 is congruent to 18, and then from that, if corresponding angles are congruent, then these two lines here are parallel. And then you can use that transitive property again. So we know that P is parallel to Q and P is parallel to R. So that means that Q has to be parallel to R, and that's using your transitive property. So if you wanted to try that one and layer that out there, figure out the order. Let me know if you have any questions. All right, number 10, 1 and 7 are supplementary. So let's take a look at that. 1 and 7 are supplementary. Well, looks like we're going to have 1 and 6 are vertical, so they're going to be congruent. So then I can say 6 and 7 are supplementary. I'm going to do some substitution because I'm going to have to substitute in a 6 in place of a 1. So I'm going to have to use my definition of congruence on this for that substitution. If I can say that 6 and 7 are supplementary, then I can say the lines are parallel because they're consecutive interior. All right, so let's take a look. Number 1, angle 1 and angle 7 are supplementary. Oops. Missed my 7 there. So number 2, the measure of angle 1 plus the measure of angle 7 is equal to 180. And that's your definition of supplementary angles. If two angles are supplementary, then their sum is 180. And then I said from there, I said 1 and 6 are vertical. By the way, there's other ways to do this specific problems as well. But since I was only given so many spots here, I wanted to kind of follow along with what she had in the answer key. So I was just writing out that 1 is congruent to 6 because 2 angles are vertical, then they're congruent. And then because I'm going to do a substitution in there, because I want to get to 6 and 7 are adding together to give me 180. So I can say they're supplementary. So I can say that they're consecutive interior. So I can say the lines are parallel. All that being said, I need to convert to measurements for substitution to happen. And that's your definition of congruence. If two angles are congruent, then they have equal measure. And then step 5, I can go ahead and do that substitution. So instead of a 1 here, I'm going to put a 6 because they're congruent to each other. And then angle 6 and angle 7 are supplementary. That's your definition of supplementary again. If two angles have a sum of 180, then they are supplementary. And then since 6 and 7 are supplementary and they're consecutive interior, then I can say that A is parallel to B. And that's if consecutive interior angles are supplementary. Then the lines are parallel. All right, let's see if there's any others that we want. Ooh, number 12 is a good one to do. Number 12 is good because it talks about angle bisectors. So let's go ahead and take a look at that. That's a good refresher here. So let's start with JL bisects angle NHK, no, NKH. And I'm going to take a look at that because that bisection has given me something. NKH. Let's see where that is. NKH. So this line right here that's cutting across that I'm highlighting or that I'm pointing at is bisecting this angle. So that means that angle 1 is congruent to angle 2. And that's if a line bisects an angle. Then it divides it into two congruent angles. That's your definition of an angle bisector from last unit. All right, let's see where we're going here. We also know that JL is parallel to FI. So let's write it down and then we'll see what those parallel lines give me. So my third statement here is my given statement. I'm going to highlight those and see what becomes of that. So JL and FI are parallel. Okay, so with those being parallel, then I know 2 and 3 are congruent because 2 is alternate interior with 3. Then it looks like I'm going to have to use a transitive property here. So if I can say 2 is congruent to 3, oh, look at, we also have 3 is congruent to 4. So we have a vertical angles, we have a couple transitive properties. So 2 is congruent to 3. We'll be able to say 1 is congruent to 3 because of the transitive property. And then I have 3 and 4 because they're vertical. And then you can use your transitive property to say 1 is congruent to 4. So we have a couple transitive properties here. So let's go ahead and work our way through that. So because what were those angles? 2 and 3. So angle 2 is congruent to angle 3. And that came from the parallel lines. So if two lines are parallel, then alternate interior angles are congruent. So that's good news. And from that, using 1 is congruent to 2 and 2 is congruent to 3, then I can go ahead and say that because they're congruent to 2 together, I can use my transitive property for step 5 to say angle 1 is congruent to angle 3. That's good news. And then we also had vertical angles in there. So 3 and 4. I knew I had to have a 4 in there somehow because the final statement says 1 and 4 are congruent. So I knew I had to kind of keep going with those vertical angles. So I had to look at my picture to see what was happening there. So 3 is congruent to 4. And then that's if two angles are vertical, then they're congruent. And then that sets us up for the last step. 1 is congruent to 3, 3 is congruent to 4. Using your transitive property, you can say 1 is congruent to 4. It's not really given. Transitive property. All right, let's see. Number 13, P is parallel to Q. Well, if P is parallel to Q, then I can say that 2 is congruent to 3 because they're alternate interior angles. We eventually need to get 2 and 5 congruent. So let's at least start there, and then I'll take my highlight off. So angle 1, P is parallel to Q. Step 2, that gave us angle 2 is congruent to angle 3. Two lines are parallel. Then alternate interior angles are congruent. All right, we also know L is parallel to M. I'm gonna erase what I have, my highlight lines, and re-highlight another set. So this time L and M. So let's see, 3 and 5 are congruent. I knew I needed 5 in there because instead of 3 and 4 being supplementary, I knew in my final I needed 2 and 5 to be congruent. So that's why I kind of made my search go to 5. So angle 3 and 5 are corresponding, and because these two lines are now parallel, we can say corresponding angles are congruent. Angle 3 is congruent to angle 5. Two lines are parallel. And corresponding angles are congruent. And then just like the last one, we now have a transitive property again. 2 is congruent to 3 from step 2, and 3 is congruent to 5 from this last step that we just did. So angle 2 is congruent to angle 5 through your transitive property. All right, have more going on the next page. Let's see if we have any good ones. Let's see. Oh, yeah, number 14 is a good one to go over. All right, so let's see. This one's got quite a number of steps. It has 11 steps. But let's first start with AC is parallel to DF. So step 1, AC parallel to DF. So parallel lines give us some special angles that are congruent. Let's see what we got here. Let's see. DB. Okay, so this angle right here. So it's 1 and 2 combined, give us DEB. DEB is the when you add 1 and 2 together. And this angle here, 3 and 4 added together, give us, what is that? CBE is this angle that's 3 and 4 combined. Those are alternate interior angles, so I know they're equal to each other. So let's add that in there from those parallel lines. Angle DEB is congruent to angle CBE. And that's if two lines are parallel. And alternate interior angles are congruent. Now we kind of touched upon it a little bit. We're going to have to do some substitution in here, so I'm going to convert over, but let's talk a little bit about 1 and 2 together. When you add them together, these two angles will make up DEB, and then 3 and 4 added together are going to give us CBE. So we're going to use our angle addition postulate coming up here, which will lead to some substitution and things like that. So I'm going to use my definition of congruence for these angles. Now, sometimes you don't know that right off the bat, and you just do the problem, and then you kind of have to backtrack and maybe squeeze the definition of congruence in there. So just be aware that it's not always something that you see right off the bat, especially as you go through some of these newer problems. So if two angles are congruent, then they have equal measure. And then I'm going to use my angle addition postulate there. So the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle DEB. And I'm going to do the same thing with 3 and 4 while I'm here. So the measure of angle 3 plus the measure of angle 4 is equal to the measure of, what was that, CBE. Next up, we can say since these two angles here are congruent to each other, because we just said it in step 3, then I can say that measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle 3 plus the measure of angle 4. And that's using your substitution property. It is not transitive, because this is, if we had made it DEB and we made a step in there, we could have gone ahead and did the transitive property, but because we didn't write out that step, I'm just going to use substitution. Now, if you were doing this problem yourself and you wanted to go ahead and add in that step, that's perfectly fine. I did not. All right. We also know that from up here in the given, the measure of angle 1 is equal to the measure of angle 4. Oops, I got a 2 up there. So I'm going to substitute out a 1 and put a 4 in its place. And that's also substitution. Number 9, we can use subtraction to subtract out those measurements of angle 4. So you have the measure of angle 2 is equal to the measure of angle 4. No, 3. So that's your subtraction property. All right, so let's see where I'm at here. Let me go back up. We're trying to show that, let me erase what we have here. Trying to, and in the end, show that AE is parallel to BF. So these two lines. So let's see, here's our transversal BE. Let's fix that up. So let's see if we can show that 2 and 3 are congruent, which we just did in that last step, step 10. Then I can now say, because 2 and 3 are alternate interior angles, I can now say that those lines are parallel. Let's go back to our definition of congruence. Now we can say the lines are parallel because we found 2 and 3 are congruent. So AB parallel to BF. If alternate interior angles are congruent, then the lines are parallel. All right. So let's see, number 15, I'm not going to go ahead and do that, but you will have to use some definition of congruence. You'll have to use transitive properties here because you have three lines that you probably assume we're going to have to prove. But because we're dealing with supplementary, and you see here we're trying to prove 7 and 5, the measurements add together to give you 180, you're going to have to convert over to a definition of congruency for some substitution coming in. So hopefully go ahead and give that a try. But if you are struggling, let me know. We can always double check that one together. So good luck with these.